Okay, welcome. We're going to be talking about word problems with radicals today. And radicals, we're going to be doing just the same as we were with solving, but just using word problems. So the main thing is deciphering what we know and what we don't know. Okay, problem one. We are given a distance formula. You should recognize this. So the x value of the second point minus x value of the first point squared plus y value of the second point minus y value of the first point squared, square rooted, is the distance between any 2 points. Okay, so we're given a point. Point is 2, -3. So we're just going to call that point 1. We're trying to find point 2. And what we know about point 2 is it's on the x-axis. So the y value is 0. We don't know the x value. But we do know our distance needs to be exactly 8 units. So if I were to rewrite this distance formula, substituting in what I know, distance we want to be equal to 8, which is the square root, x2, so my second point, I don't know what the x value is in my second point, so we're just going to call it x, minus the x value from the first point, which is 2, squared, plus y2, which is 0, minus x value, or y value from the first point. So 0 minus a -3 squared. Okay, let's clean this up a little bit. 8 is equal to the square root of x minus 2 squared plus 0 minus a -3. That's 0 plus 3, which is 3, squared. 3 squared is 9. Okay, already looking better. And from solving, we know once we have the radical isolated, we need to square both sides. So let's square both sides. On the left, I have 64. On the right, the radical cancels with the squaring. So we have x minus 2 squared plus 9. Okay, we need to multiply this out now. So we still have the 64 hanging out. X minus 2 squared, remember this is x minus 2 multiplied by x minus 2. So you're either going to need to FOIL or box. I'm going to go ahead and FOIL. So I have x squared, x times -2 is -2x, -2 times x is another -2x, that's -4x, -2 times -2 is +4, plus I have that 9. Okay, it's a quadratic. That means everything has to be on the same side to factor it or solve. So subtract the 64. I have 0 is equal to x squared minus 4x. All of that combines to -51. Okay, do we have factors of 51 that add to -4? And we don't. So remember how we solve for this. Our quadratic formula, -b plus or minus square root b squared minus 4ac, all of that divided by 2 times a. So let's substitute into our quadratic formula. -b, so -4 becomes a +4, plus or minus b squared, so -4 squared is 16, minus 4 times a is 1, and c is -51. All of that over 2a. A was 1. Okay, let's see what we've got here. Still have the 4 out front, plus or minus square root 16 minus 4 times 1 times a -51. Okay, 4 times the -51 is 204, and it's negative, but we're subtracting. So that becomes a positive. 16 plus 204 gives me 220 over 2. Oh, just like we've been doing, I might have to extract any roots that are in 220. And 220, 4 goes into that 55 times. So let's, the square root of 4 is 2 times the square root of 55. So I'm going to replace the square root of 220 with 2 square root of 55. I have 4 plus or minus 2 square root of 55 divided by 2. And look at that, 4 goes in, or 2 goes into the 4 and into the 2. So my number is really 2 plus or minus the square root of 55. And it's always a good idea to look back and see what the problem was asking us. In this case, we had to identify the points on the x-axis that are exactly 8 units away. So this is the x value of my points. So my first point would be at 2 plus the square root of 55, comma 0, because it's on the x-axis. And we would have a point at 2 minus square root of 55, comma 0. Both of these points are on your x-axis, and they're exactly 8 units away from our original point of 2, negative 3. Do not plug these in your calculator and find out what negative 50 or what the square root of 55 is. We want it just like that. Okay, let's take a look at one other problem. Let's do, how about problem number 4? That one looks like it might be a little tricky. Okay, so we're dealing with buying a new car and we drive it off the lot. And as hopefully most of you know, when you drive it off the lot, its resale value drops. That means what you could sell it for. It's going to be less than what you paid. This is one of the reasons a lot of people don't like to buy new cars. So we've got an equation, r equals 1 minus the cubed root of v divided by c. R is our depreciation rate. Our rate is 7%. Now we cannot plug in our percentage rate. We have to put it as a decimal. So 7% equals 0.07 as a decimal. So let's rewrite this equation with 0.07 for r, 1 minus the cubed root. V represents the immediate resale value. That's what we don't know. So I'm going to leave the V in my problem. C represents the original cost of the car. So in this problem, we bought the car for $29,500. Okay, so there's our problem. And now we need to solve for V. Okay, first thing I need to do is isolate the radical. So let's subtract the 1. So we have 0.07 minus 1 is negative 0.93 is equal to a negative cubed root of V divided by 29,500. Okay, we could just cube both sides, but I'm going to get rid of these negatives to begin with. So if I divided both sides by negative 1, I get 0.93 is equal to the cubed root of V divided by 29,500. And it just makes it a bit easier, I think, to see what's going on. So let's cube both sides. So cubing a cube root, those cancel with each other. 0.93 cubed, I want to leave as many decimal places as I can till the end of the problem. So this gives me 0.804357 equals V over 29,500. Okay, so now to find V, I need to multiply both sides by 29,500. And to minimize our rounding errors, we're not going to round until the very last step. So we multiply these and I get V equals 23,728, and it says to round to the nearest cent, so I need 2 decimal places. So that will round to 53 cents. So that $29,500 car was only worth $23,728.53 when I drove off the lot. You already lost over, gosh, almost $6,000. Not a good deal. Okay, good luck on the rest of the problems. Do make sure you pay attention to units. So for instance, on problem 5, you've got some of the information is in kilometers, some is in meters. So you'll have to make sure you use the same unit throughout the problem.